In order to understand how atoms turn into ions, it's important that we understand a little bit about the periodic table. Um, there are some areas you need to know in order to work your way around. There will be several families. You need to memorize the following families as you see them here in groups. It'll help us as we have our discussion about the working of the periodic table. As you can see, the periodic table is made up of 7 horizontal rows running from left to right across the periodic table. We'll just take and focus on potassium through krypton here, 19 through 36. These horizontal rows running from left to right across the periodic table are known as periods. Sentences runs from left to right. What's the end of a sentence? A period. It's one of the ways that I remember it. Really what it stands for is that what you're going to find, and we'll do a lab on Wednesday, in which you see that physical and chemical characteristics of these elements repeat themselves every so often. They repeat themselves periodically. We get this periodic, if we lay these all out in a row, we get a periodic occurrence of both the physical and the chemical properties. Okay. The periodic table, as you notice, also is arranged in 18 vertical columns from top to bottom. If we just take this very first group here, and from top to bottom, vertically speaking, we call these groups. Or it's very common that you hear the word family. Groups or families. It's common we talk about a family tree. Trees grow vertically up and down, so you remember that that's a group or family. We'll start to add much information to this using the ideas of groups and families and rows, periods. Okay, I'm going to erase that. And it's important that we know the names of these families so we can keep track of which elements belong in what groups. Okay, the first family that we look at here in column 1, known as the alkali metals. The second family, known as the alkaline earth metals. And then there's a pretty big block here from 21 to 30 all the way across. It really does extend and include and even some of the elements of there we'll talk about. Some of these down along this area down here, they're referred to as the transition metals. We'll look at the definition. It's really this big block in here, and includes a few down in there. The next 4 families are called by elements that are in their particular families. We have the aluminum, carbon, nitrogen, and oxygen families. And there are some people who call this family by the boron family. In my estimation, the elements are more like aluminum, meaning they have more metallic properties than they do boron. And so I like to refer to it as the aluminum family. So you've got the carbon family, the nitrogen family, and the oxygen family. And that's the columns there. The next family that we come across, moving from left to right, are the halogen family. Halogen means salt former. You may have heard of halogen light bulbs, that some people have halogen lamps in your house, or halogen light bulbs that they have in cars. On the very far right of the periodic table is a group of gases known as the noble gases. You might also hear them referred to as the inert gases. If you happen to notice that there are 2 rows, 2 periods that don't appear to be attached to the periodic table, these are known as the intertransition metals. The intertransition metals are made up of two series: the lanthanide series, 57 through 71 atomic numbers, and the actinide series, 89 through 103. Now, all of these families have special things about them that we'll be referring to as we move through our units. It's very important that you memorize these families and their groupings, and eventually their physical and chemical properties. Another reminder as we look at this is to make sure that you remember that the staircase comes down on the periodic table, separating the metals from the non-metals. Metals are on the left side of the periodic table, non-metals on the right side, semi-metals touching the staircase. Trends that we find on the periodic table, we mentioned this earlier: metals tend to lose electrons to become positive, non-metals tend to gain electrons to become negative. The carbon family, it really can be a plus or minus 4, but they don't really gain or lose electrons. They tend to share, and when you share electrons, you make something called a covalent bond. You share electrons, and so carbon tends to share as opposed to gain and lose electrons. We say that noble gases are happy. I don't like to personify atoms, but maybe tend to. They don't tend to form ions, and I'll really come back and talk about what that happy means. What's it mean for elements to be happy? So in summary, you got your metals on the left side. Left lose, and so they become positive. You have your nonmetals on the right side. They gain electrons, tend to be negative. And the carbon family tends to share. We'll talk about the semi-metals as we get to them at another point in time.